Welcome again to this maths memory video, and this is taking you through the topic of experimental probability. It's a bronze tier topic, grade 4/5, and you can find this on both foundation and higher level papers. So on your revision card, let's create these separate templates. The first template, let's go through this learning objectives. We're going to show you how to calculate probabilities during this video, okay? And they're mainly used in examples using things like dice, coin spinners, things like that. That will help you, well, that is all about experimenting, hence the title. Also, we may be using ratios in some questions as well. They may be used in context, so we'll show you how to use those. And also two-way tables, another quite easy and effective way of using probability in this topic. Create a nice space for your best examples in this video, what you like, what you see of value. This is grade 4/5, as we said, and hopefully by the end of this we can get 3 clear steps to show you how to do any kind of question. Press pause to take this in. On a revision card, let's create 3 separate sections, A, B, and C, and these will be the main toolkit for you to get the best methodologies in this topic of experimental probability. So press pause and make sure you have this on a card. Question 1, back to basics, experimental probability. Now let's write this question down, parts A and B, and let's do this nice introductory framework on the basic, let's say, core elements on experimental probability. Like the name suggests, it's all about experiments on things like dice, counters, and let's say spinners, the nature of those things. Anyway, press pause, press play when you're ready. A 4-sided spinner is spun. Now, the table below shows the probabilities that the spinner will land on a 1, 2, or 4. These are the 4 different outcomes, and you can see the respective probabilities for each one of those numbers. The spinner is spun once. Okay, so work out the probability that the spinner will land on a 3. Now, this is a typical question when we need to fill in the blanks on this table. But before we do that, we need to know a certain thing about probability. All 4 of these boxes, or probabilities, will add up to 1. Probabilities add up to 1 always. It's in the decimal form. Now, sometimes it's better to convert these to percentages. If you get stuck, you don't have to. I do because it makes it a bit easier. 30% plus 15% is 45. 45% plus 25% is 70%. 100% take away 70% is 30%. Converted back to a decimal, 0.3. So all of these add up to 100%, or we could say 1 as a decimal. Whatever you do, the answer is 0.3. Okay, now Adam is going to spin the spinner 80 times. Work out an estimate for the number of times the spinner will land on a 3. So it's 80 times. It'll simply be this non-calculator. 80 times is 0.3. Or if you want to, think of 0.3 as 30%, like we always do. 30% would be this. So 10% of 80 equals 8. Therefore, 30%, this will equal, let's times that by 3, 24. Okay, so the answer would be 24. That's looking at your non-calculated version of finding this, the 10% rule. Put this in a rectangle, that might make more sense for you. All right, so the answer is 24 times. If Adam spins it 80 times, you should get the number 3, 24 times. And we got that from part A. Question 1, core 1, experimental probability. Press pause, let's write this table down, and let's answer part A for this estimate, and press play when you have completed this. Now the table below shows the probabilities that a biased dice, remember biased means unfair, will land on a 1, 2, 3, 4, or 6. So these are your different faces of the dice, and these are your respective outcomes in probabilities. So Carol rolls the biased dice 120 times. She's having fun here with the rolling of the dice. Work out the estimate, okay, it's an approximation, for the total number of times the dice will land on a 4 or a 5. This word "or" should really spring up to your mind. Okay, now let's do the same thing we did for the back to basics questions, but take it a step further with the "or." So therefore, you know, all probability adds up to 1. Let's add these up. Okay, so 25 plus 12 plus 13, that's 50%. 50 plus 25 is 75%. Add another 15, that's 90%. We'll do 1, take away 0.9. Or you can do 100%, take away 90%. This will give you 0.1. Whatever you want to do, whatever is best for you, percentages or simply the decimals, use that format. 0.1 is over here. So Carol rolls it 120 times, 4 or 5. Now 4 or 5, it's these two over here. Let's hold on to these two. If we add them together, we add them because the word or means add in probability, okay? Let's just write that in fact. Or means add. And it's worth mentioning as well, and means times, okay? But that's not over here. All right, so basically, if we add these together, 25% plus 10% would be 35%. You want to find out 35% of 120. Notice how we converted 0.35 to 35%. We always do this. It's a little trick. 35%, let's use the 10% rule. 10% of 120. Let's take the decimal back 1. It'll be 12. Let's work out now 30%. So 30% of 120. This would be times it by 3. Okay, we times it by 3 over here. We get 36. Let's figure out 5%, okay, of 120. 5% would be half of your original 10%. Let's put that in a little rectangle over here. That was our core 10% rule, remember? So 5% of 120, we half 10%, which is 12. Half of 12 is 6. Let's add this together. Let's add 36 plus 6 over here, respectively. 36 plus 6, 42 times. So Carol would get a 4 or a 6, 42 times if she did that. Okay, so that's the 10% rule. We basically converted the decimal to a percentage, and or was seen as a plus. Those are your two little gems for this question.
Let's get our first card out and let's make it section A, calculating probabilities. You should learn that all probabilities add up to 1. So this is very, very important to understand in anything, in any probability, not just your tables over here, but anything. Even if the tree diagram context comes in later on, this is so true. So make sure you get this. Press pause to take it down.
Question 2, core 2, experimental probability. Let's get a piece of paper and we're parting A and B down, and let's try to figure out these. Press play when you have finished this. And the table below shows the probability of taking at random coloured marbles from a box. We have 4 different colours, and obviously we've got just 2 probabilities over here of red and blue, 30%, 25%. The ratio that Amanda will pick a yellow marble, okay, to a green marble, or counters in this case, should I say, is 2.3. So that means for every 2 counters of yellow, there'll be 3 counters of green. Okay, for every 2 of these, 3 of these over here. Work at an estimate for the probability of picking a green marble. Now, first of all, let's use this idea of all 4 add up to 1. Okay, that's always the theme with these questions. So 30 plus 25 is 55. 1 take away 0.55 would give us 0.45. Okay, now we need to split this up into 5 different units because this 45 or 45% rather has 5 units in total that can be divisible into this. So what's 45 divided by 5? It's going to be 9. All right, so one of these, 1 unit, would be 9. If that makes sense, 0.09, 9% or 0.09. Again, it doesn't matter how you get this as long as you understand this fact, okay, by adding up the ratios. It's like total ratios, by the way. Now, if 1 unit equals this, we have 2 units representing yellow. All right, so 2 times 9, 0.18. Then this is 3 units for green. 3 times 9, 0.27. These two add up to 0.45. You can check it. It'll all make sense. So that's using ratios within the context of experimental probability. So the estimate would be green marble 0.27. Part B, there are 50 blue counters in the box. Work out the number of yellow marbles in the box. So 50 represents a 0.25. We could say 25%. Remember, we like to convert these to percentages on experimental probability. 25% is 50 times. What would well, let's work out the total number of marbles in the bag first to work out how many yellow marbles there are. So once you know the total, we can find out 80% of that. So if 25% is this, let's go up this time. What's 100%? 100% must be, well, the times is by 4 here. We times by 4, 200 times. So 200 times is how many times, basically, we do the experiments on everything over here. Okay, so we pick it 200 times. There's another way of doing this, by the way. Let's call this method 1. This method 2 as well. We could use this idea too. We could say 50 over 0.25. Okay, this is more mathematical, I would say. We times the bottom by 100 because we want to make that to a whole number, and 100 as well over here. So this is 25 over 5,000. Use the bus stop method. 25 into 5,000. If you do this, how many 25s are 50? It's 2 zeros, 200 snap. Okay, so whatever you do, 200 is the total number of times this is thrown, these marbles. Now, what's 18%? 0.18 to percentages. 18%, we'll do it over here. 18% of 200. Okay, so this would basically be, we find out 10% first, which would be 20. Let's find out 5%. Okay, 5% would be 10. And let's find out 3%. To find out 3%, we'll find out 1%, which is 2. We take it back to, remember. And then 3% would be equal to 2 times 3, which is 6. We add them together. We get an answer of 36. So there are 36 yellow marbles in the bag all together. That's how we do this question over here. Part B are 50 blue marbles in the box. Work out the number of yellow marbles in the box. Okay, let's take a different stance on this now. So 50 marbles, or blue marbles rather, this represents 0.25, which is over here. Okay, let's convert the decimal into percentage. We always like doing that on this topic. So what we're saying is 25% represents 50 blue marbles. Now let's find out how many marbles are in this bag altogether, on this box rather. All right, because once we find out that number, we can simply find out 18%, okay, because we want the yellow marbles of that number. The different ways of doing this, let's take out this first more common sense approach. Let's find out 100% first. So to get to 100%, we times this by 4, and times this by 4 as well, because we want to get the total number. So that's the total, 200. All right, once you've got that, you can find out 80%. And that's method 1. Let's call this M1 over here. There's another method as well. Let's call this method 2, a more mathematical approach, let's say. We could do 50, because 50 represents 25%. Let's find the total number of marbles in the box, divided by 0.25. Now, this can't be a proper fraction because we have a decimal. So what do? We need to multiply the denominator by a number to make it a whole number. We times that by 100. We times that by 100 as well. If we do that now, we simply get this 5,000 over 25. We can do bus stop method on that. 25 into 5,000. 25 to 50 is 2. Add 2 zeros, 200 snap. You've got 200 here. And you've got 200 here. Okay, so whatever method you want to do, it's up to you. Anyway, let's use that and find 18% of this. Okay, so 18% of 200, because 18% is the percentage of yellow. Let's find out 10% first. So 10%, this equals 20. And let's find out 5%. This is half of that, 10. And let's find out the remainder 3%. Okay, find out 1% first. Take it back to 2 decimals. 1% is 2. Hence 3% would be 2 times 3 is 6. We add these up together. Okay, so we add 20 plus 10 plus 6. Get an answer of 36. All right, so there are 36 yellow marbles all together in this box. So those are 2 different ways of doing it to make sure you understand both those ways.
Here's a second revision card for you. It's section B, using ratios. So just a quick note, make sure if you see ratios in a context of probability, use total ratios. Okay, that's the technique we did in basic ratio topic to calculate the probabilities. Add them together. That's what it means. Press pause to get this done.
Question 3, challenge experimental probability. So let's get to the grips of this question in terms of, let's show you how to create a two-way table. All right, so this is how we do it in terms of the data. Let's attempt part A and B based on this. Let's see what you can create. So press pause, press play when you're finished. Now this question is all about a two-way table, and you'll see why as we go ahead. The main thing is we have two different categories and we have the right numbers to plug into this two-way table. Anyway, let's explain. So Caelan throws a biased coin 20 times. He gets 13 tails. Mark throws a biased coin 25 times, 16 tails. Isabel a biased coin 5 times and 3 tails. So we have 3 different pupils over here, but more importantly we have a category which is, let's say, pupils, okay? And the other category could be outcomes in terms of heads and tails. So two-way table because they're 2 different categories basically. Let's create this. It'll be different for every question, but we get this from inferring it from the data. All right. Now our first heading over here, first category is pupils. We'll write pupils over here. We can write Caelan, Mark and Isabel as your 3 respective pupils, and this over here we can write this category as outcome. Okay, this is heads or tails, but heads and tails. Now it's very important we put total over here and total over here as well to find the total number of, let's say, times these pupils played this, and also the total heads and tails. Anyway, let's fill in the blanks what we have. Caelan, 20 times he throws this, so the first column, 20, this would be 13 tails. The remainder, 20 take away 13, he would have got 7 heads. Same thing for Mark, 25 times, he got 16 tails, and 9 would have been over here. Isabel threw it 5 times, you got 3 tails, the remainder is 2. Let's add up all these together, the total number of heads that were thrown, 9 plus 7 plus 2, 18. Total over here is 13 plus 16 plus 3, 32. We add these together, we get 50. And 50 is a checkpoint for 20 plus 25 plus 5, or 18 plus 32. Once we have this, we can now fill up anything we want to from here, or any question rather, we can attempt from this. Whose result will give the best estimate for the probability that the coin will land on tails? So whose result this is, okay, for the best estimate. It's not asking you the highest number of tails by pupil, it's asking you the best estimate, okay? The best estimate is the person who throws it the most. Who throws it the most? It'll be obviously Mark. All right, so it's Mark because he threw it the most. It's the highest number of throws, let's say, within a sample, to put it more mathematical, okay? But this is fine, Mark, because he threw the coin the most, okay? That's 25, by the way. Okay, Layla throws the coin once. Use Caelan, Mark's and Isabel's results to work out the estimate that Layla will get tails. Well, it could be any person. We just happen to choose Layla over here. How can we best use these 3 pupils to, let's say, approximate the best way of getting them the total number of tails? So 32 out of 50 would be the result, because the next time someone throws this, if you look at this, 32 is the total number of tails. 50 times altogether, that's what all 3 approximate to, or in terms of you add all 3 together. So this would be the same thing as 16 over 25. That's how many times you'd expect her to get a tails, just over half. After the first throw, Layla throws the coin the second time. Hence, using part B, work at the probability that she would have thrown a tail on the first attempt, i.e. over here. All right, 16 over 25. And the word and means times. A head on the second. Now a head would simply be 18 over 50. It's the same way we did the tails, by the way. Okay, so it's a tails over here times a head. So if we break this down, this is the same thing as saying 16 over 25 times 9 over 25. This is non-calculator, by the way. Let's try to attempt this. Now we can't break down anymore, so we'll do top times top, bottom times bottom. 16 times 9, this will be 144. 25 squared, 25 times 25, you can use long multiplication, but it will be 625. So that's the answer. It's a probability, and this is what she would get, 144 over 625. Here's an example you copy down on your revision card, section C. This is what you've just learned just now on how to create a two-way table. So this is what you do. Look at this kind of method, this structure, and obviously apply it to your own examples once you understand this basic table.
So here we are at the end of this video, and let's see what we have learned during this video. Maths Memory Experimental Probability. So have you been able to calculate probabilities in a table in the context of, let's say, spinners or coins? Do you know that all probability adds up to 1? Again, that will really help you. Probabilities are obviously given as fractions, but make sure you understand how to convert them into decimals when dealing with tables. And also, maybe worthwhile, will Maths Memory convert things to percentages as well. That might help you because percentages add up to 100 as well. Okay, do you understand how to use ratios in the context of this topic as well? Ratios meaning total ratios. If you go back to basic ratios, add them together. That's a big hint. And then two-way tables, something a bit different, but it's a bit more common sense. You create a table of two different categories and fill in the gaps. Okay, you should always have a total row and a total column at the end, and you can work backwards to find out the missing values. Go through the question we did in this video. If you understand those three, you should be well on the way to getting a good mark in your experimental probability topic. Grade 4/5, as we said. We haven't had any 3 steps in this because all the questions are quite varied, all different, but I'm sure that you have understood enough from these 3 different topics. In any case, let's press pause to go over our toolkits before we hit our Let's Do It questions all by yourself.
Here is your consolidated My Toolkit. So make sure you have all these 3 different sections on your Maths Memory card. So we're going to be using this for our Let's Do It questions to come right now, so you can apply the concepts you have learned onto your questions to do yourself. Question 1, let's do it, experimental probability. So let's get our cards together. Let's see what you've learned. Let's put this to action by doing this. Let's do it. Question 1. Press pause, press play when you are ready. Question 2, let's do it, experimental probability. Again, let's press pause. Let's try to create a two-way table if that helps you in this question, like you did previously in the core questions A, B, and C. Press play when you have finished. Congratulations, you have now completed this topic on experimental probability, week 4 bronze tier. Let's rate yourself on your planner. How well have you completed those Let's Do It questions? How well and thorough are your revision cards to have matched those questions? Put your marks up if you can, and let's see what you have produced on that planner of yours.